Guys, we just got visited by aliens. I'm serious, I'm for real on this. About a month ago, I did a video about Oumuamua, and we talked about the possibility of it being an alien craft. We were more so focused on the fact that it swooped in from interstellar space. Now, this made me want to go bust out my 10-year-old copy of Physics of the Impossible by Chycho and look at the chapter on space travel, spaceship design. And in here, he has an excerpt on solar sails. And I'm not talking about cheap energy. Why do I make jokes like this? I was reading this article the other day, and let me just... Here we go. Got it. Solar sails. Guess probably can't see it. So this book is essentially him, Dr. Chycho Kaku, famous physicist, discussing what we have the potential to develop. And he discusses a lot of very debatable, I guess, future technologies. And in a lot of cases, some cases, he debunks them. But in other cases, he proves that it's just a matter of time before we get the technology to develop things that we suspect a future civilization, a even slightly, ever so slightly more advanced alien race would be capable of. So let me let me find this again. I know what page it's on now. And for those of you wondering, by the way, this, if you weren't, you now are, this is the book in which I first heard about the Kardashev scale. The scale by a famous Russian astrophysicist that helps us easily identify the level of energy that a civilization is capable of harnessing, I guess, starting with a planetary scale, which we're almost at, and moving up progressively, exponentially, really, to civilizations that are able to develop technology that allows them to harness entire suns, solar systems, and then beyond that, groups of stars, I guess, and then galactic, and ultimately, I guess, the universe. I don't know what scale, what number that would be. Civilization 5? Type 5? I don't know, I forget. But one proposal that may solve. So he talks about ion and plasma VASIMR, which means variable specific impulse magnetoplasma rockets, being one potential technology to help us get to stars. But he says neither the ion nor the plasma engine, however, has enough power to actually get us to the stars. So actually, sorry, he was talking about interplanetary trips. But to go way beyond that distance, go to the stars, which we're thinking Oumuamua was, our top guys and gals think that Oumuamua, they're really certain that it came from interstellar space. So for a starship to be capable of traveling those distances, if this is indeed a starship, then what? For that we would need a staggering amount of fuel. And of course a long span of time over which we could use that fuel. So a solar sail is one proposal that may solve these problems. That would be a lot of fuel, a long time to get there, being able to carry enough fuel on the trip. Is the solar sail. It exploits the fact that the sun exerts a very small but steady pressure that is sufficient to propel a huge sail through space. So a lot of you guys don't know this, but Einstein actually originally got famous before formulating his theories about specific, special, and then general relativity later. He published I think it's the paper that got him the Nobel Prize, ultimately. It wasn't even relativity, it was on the effects of the photoelectric effect, which is that it was about the nature of light, which makes him very, very much akin to Newton in his interests in physics. The photoelectric effect is essentially the energy that light imparts to objects when it hits it. And it's crazy that photons, let's see, are they massless? Photons. Particle representing a quantum of light or other electromagnetic radiation. Light is visible light. What we call light is just a very, very small range on the electromagnetic spectrum, which includes microwaves, radio waves, gamma rays, infrared lights. And so a photon is a carrier, is a force carrier for the electromagnetic force. Photon has zero rest mass. It always moves at the speed of light in a vacuum. In a vacuum. It has to be in a vacuum. So, like all elementary particles, photons are currently best explained by quantum mechanics and exhibit wave-particle duality, exhibiting properties of both waves and particles. For example, a single photon may be refracted by a lens. Sorry, I'm kind of partially reading to myself here. Trying to find the best way to... Okay. When you hear physicists on TV talking about light being waves or particles, they're actually talking about the photon. And when they try to measure a photon, just like we can measure an atom, and the electron is kind of a diffuse cloud, it's not necessarily a point particle now, unless it's, well, that's the spookiness of quantum mechanics, but things at such a small scale don't have intuitively tangible properties. They seem to exhibit properties of both waves and definite positions and velocities of particles. So the modern concept of the photon, developed gradually by Albert Einstein in the early 20th century to explain experimental observations, did not fit the classical wave model of light. The benefit of the photon model, which would be more of a particle model, is that it accounts for the frequency dependence of light's energy. Oh, okay, yeah. So if we're discussing photons, or if we're discussing light as having the properties of a wave, that's represented or visually, I guess, by peaks and valleys, and instrumentally detected, I guess you might say, empirically observed by having like pulses, I guess you might say. And the longer the pulses of detection of the light wave, the weaker it is, the shorter the pulses, the quicker it, or the shorter the distance between peaks and troughs of the waves, then the more energy the particle, or I say particle, the wave has. And that's how we define certain areas of the electromagnetic spectrum. Such as visible light being between like somewhere like 500 to 900, I think, nanometers in width. It's 10 to the negative 9 meters. A decimal point width, I guess for you guys, it would be like 8 zeros, I think. Decimal point with 8 zeros after it, and then whatever the number might be. Or no, I guess if it's in the hundreds, 500 nanometers would be 6 or 7 zeros. But why am I talking about this? I want to talk about how photons, photons meaning light, when they hit an object, they actually they impart a force on it, because they're actually units of energy. And it's crazy to think about that. So that's when you step outside into the sun, you're actually being paraded by all these photons, propelled across 90 million miles of space over 8 minutes. And that's why you get a sunburn, because the light actually is imparting a force on your body. So it explains Einstein's photon model of light, explains the ability of matter and electromagnetic radiation to be in a thermal equilibrium. Means there's no net flow of heat or thermal energy between the two when they're connected by a path permeable to heat. The photon model accounts for anomalous observations, including properties of black body radiation. The model light is described by Maxwell's equations, but the material objects emit and absorb light in quantized amounts, although these... Okay. That wasn't super useful. We're talking about solar sails and what Oumuamua might be propelled through interstellar space by. So, nonetheless, I just wanted to point out that, convey that light does, in fact, it might seem like, just because you're out standing in the sun, there's no way you're going to be physically moved by the sunlight. But, in fact, if you were floating in space, given a long enough time, and you stayed rotationally stable, I guess angularly, you had no angular velocity, so that one side of your body was facing the sun at all times, you would actually be propelled back from the sun specifically due to the force exerted on you by the sun's light. So the idea of the solar sail is actually an old one, dating back to the great astronomer Johannes Kepler in his 1611 treatise, only 5 years after the gunpowder plot. It's crazy. Although the physics behind a solar sail is simple enough, progress has been spotty in actually creating a solar sail that can be sent into space. And this book was written like 2007, I think, or 6. In 2004, a Japanese rocket successfully deployed 2 small prototype solar sails into space. 2005, the Planetary Society and Cosmos Studios, I think of Carl Sagan fame, and the Russian Academy of Sciences launched the Cosmos 1 space sail from a submarine in the Barents Sea. No, but the rocket failed and it didn't reach orbit. Let's see what else it says. Let's see what else it says here. Oh. Suborbital fails. So it says, to have a truly effective solar sail, you would have to have it hundreds of miles wide and constructed entirely in outer space. One would have to build thousands of powerful laser beams on the moon, each capable of firing continuously for years or even decades. In one estimate, so this would be technology, laser technology in conjunction to get the initial impulse of the solar sail. You would use lasers because they're so direct and so narrow. You would fire them to give the initial momentum and velocity to the spaceship. From then, once they got out of the laser's range, even though that would be ideally very, very far, they could then use the sun's light to propel them, to perpetuate their momentum onto the next solar system. This is so cool. One would have to build thousands of lasers on the moon. Estimate it would be necessary to fire lasers that have 1,000 times the current total power output of the entire planet. Wow. On paper, a mammoth light sail might be able to travel as fast as half the speed of light. It would take such a solar sail only 8 years or so to reach nearby stars. The advantage of such a propulsion system would be that it could use off-the-shelf technology. No new laws of physics would have to be discovered to create such a sail, but the main problems are economical and technical. So we can create it using current technology, but the actual production, the scale of such an engineering production would be so vast that it would take a lot of cooperation currently, and focus, and obviously a reason to construct such a large sail. possibility. Let's... I want to read this article now. Rats. Okay, so this... So you all know that the theme of this channel is finding things out. It's exploring, it's being curious, in the same vein as Carl Sagan. So I'm not one to... I try my best not to jump too quickly on the bandwagons of, especially, wild speculation. But I do love entertaining the ideas. It's fun. It's productive to me. It's stimulating to the imagination. And this headline was that the head of Harvard's astronomy department says that, as what others are afraid to say about Oumuamua, could be one of the greatest discoveries in human history. And I'm inclined to believe someone when they're speculating, more so when they're speculating about areas in their particular field of expertise. So, I have this Archaeology magazine says the top 10 discoveries of 2018. Well, I think maybe Oumuamua might be up there. It might be alien archaeological remnants. What if it is? What if it's hundreds of thousands of years old? What if it's millions of years old and it's actually just a remnant that just happened to be set towards a passing trajectory in our solar system hundreds of thousands of years ago? So this guy says his name's Abraham Loeb. I guess he goes by Avi. Avi Loeb says, I don't care what people say. It doesn't matter to me. I say what I think. If the broad public takes an interest in what I say, then it's welcome as far as I'm concerned, but an indirect result. So he's a man of science. Science isn't like politics. It's not based on popularity polls. So he's 56, just to qualify his credentials. Because, yeah, we want to be able to trust this guy, and I think we can. This guy's proven his academic credibility quite a bit. He was born in Beit Hanan, a moshav in central Israel, studied physics at the Hebrew University of Jerusalem as part of the Israel Defense Forces Talpiot program for recruits who demonstrated outstanding academic ability. Freeman Dyson, famous physicist, and the late astrophysicist John Bacall admitted Loeb to the Institute for Advanced Study in Princeton, of famous residents of Einstein and Oppenheimer. In 2012, Time named Loeb one of the 25 most influential people in the field of space. He has won prizes, written books, published 700 articles in the world's leading scientific journals. And last October, Loeb and his postdoctoral student Shmuel Bialy, also Israeli, published an article in the scientific outlet, the Astrophysical Journal Letters, which seriously raised the possibility that this is the good part, this is the crux, that an intelligent species of aliens had sent a spaceship to Earth. So this spaceship was called Oumuamua, and Oumuamua's claim to fame, its claim to fame is that it's the first observed interstellar object. Don't know if it's a comet, meteor, or intelligently designed spacecraft. So that originated outside of our solar system. So the first interstellar guest came to us from the direction of Vega, the brightest star in the Lyra constellation, which is 26 light years from us. And actually the star from which the protagonist, played by Jodie Foster in the movie Contact, in Carl Sagan's book Cosmos, heard the extraterrestrial signal. Oumuamua was actually discovered by a Canadian astronomer, Robert Wyrick, using the Pan-STARRS telescope at the Haleakala Observatory in Hawaii. Oumuamua is Hawaiian for distant messenger, and in a word, scout. So it's a scout It was discovered October 19th, 2017, suspiciously close to Earth, about 85 times further away than the Moon, which is pretty close in cosmic terms. So, just like most planets orbit what's called an ecliptic plane, which is, you don't have planets orbiting the sun like this when all the other planets are orbiting like this. It's, I guess, the flattening nature of spiral motions. Oumuamua entered the solar system from the north, so all our planets are doing this, and Oumuamua just came in from interstellar space, slung around. And what's crazy is that it didn't just, pass Saturn or even Jupiter, but it passed in between the inner planets. And for any of you guys who have, seen the distances between the planets drawn to scale, you know that that's very, very close to the sun, and to us, of course. So let's see why he thinks this might be aliens. I think reconstruction. So Loeb's just justifying his publicizing of his opinion that it might be actual intelligently designed. He says, as children, because of course if you're wrong, and speculation is not, he doesn't want to, many academics are worried about their reputation being damaged for speculating too much, veering too far away from the facts. But his defense is, as children we ask ourselves about the world, and we allow ourselves to make errors. As scientists, you're supposed to enjoy the privilege of being allowed to perpetuate your childhood in that sense. So I don't worry about the ego. I worry about uncovering the truth, which is so cool. Especially after you get tenure which means that it's hard to be fired. You have a pretty much permanent position at a university, which means permanent income, permanent access to resources. Without tenure, he wouldn't have published the article. But let's get into his actual views on it. So we've qualified him. We've explained what the aircraft, the interstellar object, was vaguely. So some of the questions regarding its alien origin were that it was subjected to observation but not long enough. There wasn't enough data collected on it. So they didn't see a trail of gas or dust that they would expect, but the object rotated on its axis for 8 hours. And during that time, its brightness changed by a factor of 10, whereas the brightness of all asteroids that were familiar with changes at most by a factor of 3. If we assume that the light reflection is constant, it means that its length is at least 10 times greater than its thickness. So Loeb says there are two possibilities in regard to this extreme geometry. One's that it's the shape of a cigar, and the other is that it's the shape of a pancake, and we're looking at it from the side. So the truth is that the same observers who examined Oumuamua's light variation reached the conclusion that if it receives a lot of gravitational pushes during the voyage, which is reasonable because it spent a lot of time in interstellar space, its shape is pancake flat. See what else we got here. Another issue, about it being from Vega is the fact that at its speed it would have taken 500,000 years to get to here from there. And in that time the position of Vega wouldn't have been there when it originated in that spot. You average the velocities of all the stars in the region, you get a system that's called the local standard of rest. Oumuamua was at rest relative to that system. It didn't come to us, it waited in place like a buoy in the surface of the ocean until the ship of our solar system ran into it. What? So only 1 in 500 stars in the system is as much at rest as Oumuamua. Wow. So all the stars in the Milky Way galaxy, you can imagine, are rotating. They're orbiting the center of the galaxy. So it's crazy that this thing wasn't really keeping up. It's almost like being in a lazy river. And this thing wasn't keeping up. It was somehow staying relatively stationary while all the other stars were orbiting continually around the galaxy. And another thing last June from the Hubble Space Telescope. It showed that Oumuamua had accelerated during its visit to our solar system. And this was an acceleration. As we all know, gravity is acceleration. Gravity of Earth, Sun. But this acceleration on the spacecraft wasn't explicable due to just our Sun's gravitational force on it, on its mass. So if it were a comet and it was emitting gas like comets do as they near the sun and get heated up, and as the gas in the comet heats up, it expels out and might give it some sort of net acceleration. But there was no gas seen being emitted from Oumuamua. If it wasn't a comet outgassing, what force caused Oumuamua to accelerate? It's previously here where Loeb enters the picture. According to his calculations, Oumuamua's acceleration was caused by a push. A push. It's crazy. So, the only hypothesis I could think of, he says, is a push from solar radiation pressure. For that to work, the object would have to be very thin, less than a millimeter thick. In other words, a type of pancake. And the Spitzer Space Telescope, in addition, found no heat emission from the object, which means that it is it's at least 10 times more reflective than a typical comet or asteroid. So what we have then is a thin, flat, shiny object. So then he says, I arrived at the idea of a solar sail. Solar sail is, like we said, a spaceship that uses photons for acceleration, as it stays stationary relative to the sun with just one side facing the sun at all times. That one side propels it in a overall specific vector direction. So Evie definitely knows a thing or two about solar sails. In 2016, the physicist and venture capitalist Yuri Milner, together with Stephen Hawking and Mark Zuckerberg and others, established Breakthrough Starship, an initiative to accelerate solar sails to 1/5 the speed of light. This is so cool. Accelerate a spacecraft to 1/5 the speed of light in order to explore the neighboring solar system Alpha Centauri, which is 4 light years away from us. And Loeb was appointed the project's scientific director. The first question we asked is whether a sail like Oumuamua could survive billions of years in the Milky Way, and we discovered that it could. Being hit by interstellar dust or gas won't wear it down. Afterward, we tried to calculate the acceleration of a solar sail would cause in an object. Okay, and we found that it was consistent with what was measured by observing Oumuamua. We have no way of knowing whether it's active, inactive engine or technology, or if it's passively floating in space, subject to the gravitational forces of our surrounding galactic objects. But if Oumuamua was created together with a whole population of similar objects that were launched randomly, the fact that we discovered it means that its creators launched a quadrillion probes like it to every star in the Milky Way. Of course, the randomness is significantly reduced if we assume Oumuamua was a reconnaissance mission. deliberately sent to our inner solar system. Now this is, like I said, it passed really close to us. Definitely close enough to observe. It passed so close to our inner solar system. It's really, really specific. It's just too specific to be a coincidence. You know, I mean, in a probability, in a probabilistic way, you know. And we need to remember that they couldn't have necessarily, well, they couldn't have known unless they made, if it was aliens, they made another pass more recently. Because we weren't projecting signals at all into outer space, any artificial man-made signals. More than 100 years ago, you know. So, if it is an alien life form, it's a fishing expedition. He thinks maybe it's a message in a bottle is what this next part comes down to. This is so fascinating. Which, you know, is what the Voyager spacecraft is from us as well. And that's why he ties it back into what he's doing with Mark Zuckerberg and crew with this project called Breakthrough Starship. Our goal is to accelerate solar sails to 1/5 the speed of light so they can reach Alpha Centauri in 20 years, which is about 4 light years away from us. And he says, I'm 56, the other guy's 57 he's working with. At that speed, we'll be able to see the pictures in our lifetimes. So I guess it'll be 20 years to get there, and then 4 years to return the pictures by light speed. I guess they would have to have enough energy in a specific laser to be able to send the data back to us. It's so fascinating, though, man. We're starting to branch out into space, and I think we need that impulse of exploration to fulfill our desire to understand the universe more. You know, we need to be exploring ourselves, but it will, like anything, you know, if you're left alone too long, you have a skewed perspective of who you are as a person, because we're social animals at heart, and we identify and define ourselves by comparing ourselves to one another, and in the most scientific of technical terms, we use comparative methodology. Comparing data sources from as many sources as possible to arrive at truth. And you want to have sources that align and what's the word? Converge rather than diverge. And the more sources that you can gather to verify a point of observation or speculation, the more likely it is to be real and true. And so I think the contact with aliens would be it would be such a profound experience that it would open a million more doors into exploring ourselves in relation to another species of sentient beings And as far as future technological speculation, we're going to be building more telescopes to be able to, in the future, in the near future, they're going to be building the LSST telescope. It'll be far more sensitive than the Pan-STARRS telescope that identified Oumuamua. And then we'll definitely be able to see many more objects, hopefully, that have originated from interstellar space and be able to more accurately define Oumuamua as being intelligently designed or not. The rest of the articles speculating about how aliens would perceive us, how we would perceive aliens. And of course, the radio signals broadcast during World War II would not make us look extremely intelligent in a lot of ways. And hopefully I'll put this article, it's by Haaretz.com, HAARETZ.com, and I'll also link Rendezvous with Rama in the comment section, because he's now talking about if we develop more sophisticated detection sensors on our satellites to be able to detect future anomalies from interstellar space especially, then perhaps we'll even be able to gather a spacecraft to go rendezvous with it in its orbit or its trajectory in time to really probe it. And the book Rendezvous with Rama was Arthur C. Clarke was just brilliant in his. It's set up like an exploration, you know. So Rendezvous with Rama. What? There was a movie? Oh. It's a bunch of fan art film trailers for it. Yeah. In the book, Earthlings discover and investigate an interstellar asteroid. So in the book, yeah, it ends up being a spaceship, really just more of an object. It was like a mile, it was miles long, miles wide, and so it had the ability to have its own ecosystem inside it, especially when it was revivified with light from a close approximation to close flyby to any stars or other light sources, I guess. But it's got to be stars. Or an accretion disk burning up around a black hole, I guess, might be another one. But it was cool because its intention, Arthur C. Clarke designed it to be a pretty ingenious way to go around the galaxy and obviously be passive enough to observe life forming on planets if the life on the planets isn't advanced enough to be able to construct a spaceship to go out and rendezvous with it. But if they are, it was so sophisticated, this cylinder, that it was able to accommodate, and even in the way that that movie Annihilation kind of did, it was able to very, very quickly adapt to the needs and familiarities and environments that humans were familiar with inside the spaceship itself, and act like kind of a very inviting, a very hospitable interior to this huge world, essentially, drifting world, to these humans that had went to explore it. I guess in an attempt to essentially learn as much as they could from the humans in the book. And there was like these creatures that weren't quite living, but weren't quite mechanical. They were some very sophisticated, advanced, benevolent, benign, inquisitive technology, android species things. And the whole book is a handful of humans exploring the inside of this ship, and then the ship goes on, and I think it gives some of the humans enough time to leave and go back to Earth if they want to, but then some, I think, maybe get unwittingly trapped in it. But it ends up being so, I don't know, so intriguing, so interesting that they're okay in some senses staying within it and actually having progeny and developing, procreating, raising entire families as they go around the galaxy, and then being put in stasis in between trips, in between stars. It's and of course all the mechanisms by which the interior of this interstellar world are elucidated in beautiful prose and articulation and scientific understanding and comprehension in a way that's very technical yet artistic. So the book's a great read, honestly. I would highly recommend reading it to any of you guys, especially now that we got truth being even stranger than fiction, possibly. So let's see where this article ends up. And so, to Enrico Fermi's paradox, where is everybody? His reply is that they're all dead. Definitely most of them. Our approach should be an archaeological one. In the same way that we dig around the ground. I guess I traded it in. Those two preemptive in doing that, but he thinks we should approach it in that way. That it might be a relic of a very, very distant, far away civilization somewhere else in our galaxy. So it isn't easier and therefore more scientific to assume that we're alone until it's proved otherwise. And this guy says, no, that's just being arrogant, assuming that we're alone. My premise is, he says, is cosmic modesty. Today, thanks to the Kepler Space Telescope, we know that there are more planets like Earth than there are grains of sand on all the shores of the seas. pretty good analogy. He says, imagine there's a king who manages to seize control of a piece of another country in battle, in a horrific battle, then thinks of himself as a great, omnipotent ruler. Then imagine he seizes control of the entire world. It would be like an ant that has wrapped its feelers around one grain of sand. On a vast seashore, it's meaningless. It's, assume we're not the only ants on the shore, and that we're not alone. He says, in his interlocutor here is saying, that's just speculation, though. You don't know that that there's other ants, so to speak, for certain. And he says, well, the search for terrestrial, extraterrestrial life is not speculation. It's a lot less speculative than the assumption that there's dark matter, invisible matter that constitutes 85% of the material universe. And that's actually something I want to do a video on as well. Yeah, he goes on to justify why there might be life on Earth, and therefore why Oumuamua is, very probable. It's more probable than we might think that it's constructed and not just debris. Actually intelligent. So at the very end of the article it says, if there are a lot of civilizations more developed than ours that were liquidated or that liquidated themselves, that's not a good sign for us. He says it will be an excellent sign. It will give us second thoughts about what we're doing here and now, so that we won't share the same fate. We need to comport ourselves much more decently and less militantly with one another, to cooperate, to prevent climate change and settle in space. That should lead to a good place. The basic question is whether people are good at heart. I believe they are as soon as it becomes clear that there really have been many civilizations that have become extinct. I believe that will be sufficient for people to learn the lesson. And if we discover remnants of advanced technologies, they will prove to us that we're only at the start of the road, and that if we don't continue down that road, we will miss a great deal of what there is to see and experience in the universe. Imagine if cavemen had been shown a smartphone, the one you're using right now. What would they have thought about this special rock? Now imagine Oumuamua is the iPhone, and we are the cavemen. And he's comparing himself to other scientists who might take the really conservative, no, it's just a rock approach. You might ask him, where do you come off claiming it's not a rock? Clearly, he doesn't think Oumuamua is simply a dead object floating from interstellar space that just coincidentally happen to closely pass through our inner terrestrial planet neighborhood. Very, very cool. So I'm fascinated by this stuff, and clearly a lot of you guys are too. So it's just awesome for me to be able to share this with you, and you guys showing your support in return. So thank you so much for really just supporting the channel by watching, liking, doing whatever you do. If you want to share it, it's fun, it's meaningful, and I have a blast doing it. So thank you guys, and I'll see you next time.